In this video, we're going to look at an example of finding the surface area of a solid of revolution. So we want to set up but do not evaluate an integral that gives us the surface area if we rotate the curve y equals inverse tangent of x about the x-axis on the interval from 0 to 1. So remember, to generate surface area, we can imagine just rotating the graph of the curve and not the area under the curve. The area under the curve would give us the solid. That top part of that area, or better said as the graph of the curve, would give you the surface area that we're interested in. Since we're going about the x-axis, our formula for our surface area is 2 pi integral from a to b of y ds. Remember that y is representing what the radius will be for any slice that goes around the x-axis, and the ds is our arc length approximation. So in these problems, that ds is either going to be, it's always going to be square root of 1 plus derivative squared. It'll either be f prime of x or g prime of y, depending on if you have a function of x or a function of y. So in this case, the function is presented to us in terms of x, so we actually need to plug in something for y. So I plug in inverse tangent of x for y. And then my arc length formula, I'm going to use the square root of 1 plus derivative squared. The derivative of inverse tangent is 1 over 1 plus x squared. So I get 1 plus the quantity 1 over 1 plus x squared under the radical. And that's probably good enough because they tell us that just that we want to set up the integral. But if you want to play around with some algebra, you can get to this point here and have the surface area as 2 pi times the integral from 0 to 1 of inverse tangent of x times the square root of x to the fourth plus 2x squared plus 2 all over 1 plus x squared.